On the Bolivian Altiplano, at an elevation of approximately 12,800 feet above sea level, there is a site called Puma Punku. It contains hundreds of stone blocks, some of them weighing over 100 tons, scattered across several acres as if thrown by some immense force. The blocks are made primarily of andesite and red sandstone. Many of them are cut to shapes that repeat exactly, the same angles, the same dimensions, the same sub-millimeter tolerances, repeated across block after block. The most analyzed of these are the H blocks. They are called H blocks because their profile, when cut in cross-section, resembles the letter H. Each one contains a series of precisely cut channels, flat planes, and interlocking surfaces. When two H blocks are placed side by side, they fit together with no visible gap. Researchers measuring the flatness of these surfaces have found variations of less than 1 millimeter across the entire mating face. There are no chisel marks anywhere on the site. None. Not a single tool mark consistent with stone carving has been identified on any block at Puma Punku in the archaeological record. In a stone-carved site, chisel marks are everywhere. You cannot carve stone without leaving them. These blocks do not have them. In 2022, a chemical analysis of the andesite blocks found something that should be impossible. We'll get to that. But first, where these stones came from, and what it took to get them here. Puma Punku is part of the Tiwanaku complex, a pre-Columbian archaeological site approximately 45 miles west of La Paz that the mainstream timeline dates to approximately 500 CE, with construction activity continuing until around 900 CE. The Tiwanaku culture was sophisticated by any standard. They had large-scale agriculture, complex social organization, and a tradition of monumental stone construction. But the conventional archaeological account of Puma Punku has persistent problems that have not been resolved in decades of research. The primary stone used at Puma Punku, the andesite in the H blocks and the most precisely worked pieces, does not come from anywhere near the site. The nearest identified source of this specific andesite is the Copacabana Peninsula, on the southern shore of Lake Titicaca. That quarry is approximately 60 miles from Puma Punku. And it sits roughly 800 feet lower in elevation than the construction site. Moving multi-ton stone blocks 60 miles across the Altiplano, a high-altitude plateau at nearly 13,000 feet elevation, and then raising them approximately 800 feet upward in altitude, without wheeled transport, without draft animals large enough for the task, without any technology that the archaeological record assigns to the Tiwanaku culture at this period, this is a logistics problem that conventional archaeology has not solved. The answer most often provided is rafts on Lake Titicaca and then overland sledges. Lake Titicaca is indeed between the quarry and the site, and the water route shortens the land journey. But the raft solution requires constructing vessels capable of carrying blocks of 100 tons or more on a high-altitude lake at 12,500 feet elevation, and no evidence of such construction in the regional archaeological record has been found. The site presents two problems that must both be answered: how the blocks got here, and how they were cut to the tolerances they display. The 2022 chemical analysis suggests that one of those questions may have a different answer than anyone expected. To understand why the precision of Puma Punku's stonework is anomalous, it helps to have a frame of reference. Modern stone carving using diamond-tip saws, CNC milling machines, and precision measuring instruments routinely achieves tolerances of a fraction of a millimeter. Industrial stone fabrication for architectural purposes achieves tolerances of 1 to 3 millimeters across standard block dimensions. The H blocks at Puma Punku achieve tolerances of less than 1 millimeter across mating surfaces that span the full width of blocks measuring up to a meter or more. The channels cut into these blocks are perfectly straight, with flat bottoms and vertical sides, maintaining their dimensions along their entire length. The angles where surfaces meet are exact right angles, confirmed by measurement, not visual inspection. These results are achievable by modern precision manufacturing. They are not achievable by hand-carving stone with copper or stone tools, regardless of skill or patience. The physical properties of manual carving tools do not produce flat surfaces at this level of precision. Every manually carved stone surface in the archaeological record shows microvariation from tool contact. The Puma Punku H blocks do not show this variation. This has been the central anomaly at the site for decades. How do you explain precision that exceeds what hand tool carving can produce, in a culture that had no machine tools? There are two possible answers. Either there was a technology for stone working at this site that left no physical trace and has no parallel in any other known archaeological context, or the blocks were not carved. In 1982, a French chemist named Joseph Davidovits published a hypothesis that was almost universally dismissed by Egyptologists and archaeologists at the time. Davidovits argued that many of the stones in ancient megalithic structures, the blocks of the Egyptian pyramids, and potentially other sites, were not quarried and carved from existing stone but were cast in place. Specifically, he proposed that ancient builders had developed a form of geopolymer concrete, a castable stone substitute made from crushed limestone or other minerals, mixed with water and alkaline activators, poured into molds, and left to set. Geopolymer concrete is real. It is a well-understood modern technology. Unlike Portland cement concrete, geopolymer concrete can be made from natural mineral materials available to ancient cultures. When it sets, it is chemically and physically indistinguishable from natural stone to most analytical methods. Davidovits's hypothesis was initially dismissed because no one could prove it. The standard analytical tests applied to pyramid blocks returned results consistent with natural limestone. Then more sophisticated analyses were applied. In 1987 and subsequent studies, researchers found microscopic signatures in certain pyramid blocks, including air bubbles from mixing, organic material consistent with binding agents, and chemical ratios inconsistent with the quarry source material that supported the cast hypothesis. The debate has continued, with periodically updated evidence on both sides. In 2022, a chemical analysis was conducted on the andesite blocks at Puma Punku. Andesite is a volcanic igneous rock. It is formed by the solidification of volcanic magma under specific temperature and pressure conditions. It does not naturally contain organic material. Organic material, carbon-based biological compounds, cannot be present in volcanic rock because the formation process occurs at temperatures that would destroy any organic compounds. The 2022 analysis found organic matter inside the Puma Punku andesite blocks. If the blocks are natural volcanic andesite, this is impossible. The explanation consistent with the chemical finding is that the blocks are not natural volcanic andesite. They are geopolymer, cast from crushed andesite aggregate, mixed with organic binding agents, poured into molds, and set. The organic material from the binders was preserved within the matrix of the cast stone. If the Puma Punku blocks were cast rather than carved, two things follow that reshape the entire picture of the site. The first is that the sub-millimeter tolerances stop being anomalous. Cast stone takes the shape of its mold with essentially perfect fidelity. The precision of the H-blocks is not the result of advanced carving, it is the result of precise mold making. A wooden or clay mold machine to the correct dimensions would produce stone blocks of consistent geometry with no chisel marks, because there is no chiseling. The tools required to produce these blocks were tools for making molds, not tools for cutting stone. That is a very different level of technology, and one entirely plausible for a sophisticated ancient culture. The second consequence is more significant for the dating question. Carbon dating requires organic material. Natural stone cannot be carbon dated because there is nothing in it with a carbon-based biological history to date. This is why most ancient stone structures are dated by indirect means, stratigraphy, associated organic material found nearby, the style of associated objects. The conventional date for Puma Punku, approximately 500 to 900 CE, is based primarily on pottery and organic material found in soil layers at the site. It does not come from the blocks themselves. If the blocks are geopolymer and contain organic matter from the binding agents used to cast them, they can be carbon dated directly. That test has not been done at scale. The results of such a test could confirm the conventional dating, or they could produce a date that has no relationship to the pottery evidence. The conventional dating would remain valid for the pottery, the blocks might tell a completely different story. This is not a minor methodological footnote. It is the central unresolved question at Puma Punku: when were these blocks made? The absence of a direct dating test on material that appears to be directly datable is itself a question worth asking. The documented anomalies at Puma Punku form a consistent list. Sub-millimeter surface tolerances on stone blocks of a precision that manual carving tools cannot produce. Repeating identical geometries across hundreds of blocks, the kind of consistency you get from standardized molds, not from individual artisans carving by hand. 0 chisel marks on any surface at the site. A quarry source 60 miles away and 800 feet lower in elevation, with no clear logistical account of how multi-ton blocks were transported across that distance and elevation gain using the technology the archaeological record assigns to the culture. And a 2022 chemical finding of organic material inside volcanic rock material that cannot exist in naturally formed andesite that is consistent with geopolymer casting and inconsistent with natural stone. Each of these anomalies has a conventional explanation that can be argued. The precision was achieved by skilled craftspeople over many years with stone and copper tools. The transport used labor, rope, and sledges. The organic material analysis requires further validation. But taken together, they point toward a coherent alternative that the blocks were cast, not carved, using a geopolymer technology that has been documented as chemically feasible by modern researchers. If that is true, the construction logistics simplify dramatically. You do not move finished 100-ton blocks 60 miles. You move crushed andesite aggregate transportable in small loads over many trips, and you cast the blocks at the final location. If that is true, the precision is explained. Molds explain the geometry without requiring impossible hand-carving skill. And if that is true, the carbon dating question becomes urgent. These blocks may be far older than the pottery evidence suggests, or they may confirm the conventional date. Either answer is worth knowing. The test has not been done. The question has not been asked loudly enough. At a site that has been studied for over a century, the most fundamental question about the blocks, what are they made of, and when were they made, remains unresolved. That is not science stopping at the boundary of what's comfortable. That is science not yet fully arriving at the boundary at all. Next week, we cross the Pacific Ocean. In Micronesia, there is a city built on 92 artificial islands in the middle of a lagoon. The stones that built it weigh up to 50 tons. The nearest source of this stone is 30 miles away across open ocean. The U.S. National Park Service, in its official management documentation, states that the construction method is unknown. No one built a city like this. The record agrees it happened. Neither the who nor the how has been answered. Subscribe. We're going somewhere that still doesn't have an explanation. ## production notes. Voice is Brian, 11 Labs NPCZCJZI2 Dev NBZ1ZQRB. Key sources to cite in description: Joseph Davidovits Geopolymer Research, 2022 Chemical Analysis of Puma Punku Andesite, specific paper to source, Standard Tiwanaku Archaeological Literature for contrast. Frame the geopolymer thesis as a legitimate chemical hypothesis under active investigation, not fringe. Davidovits is a credentialed chemist. Do not frame as ancient aliens. The geopolymer hypothesis is a technology question, not a civilization origin question. Emphasize the carbon dating gap as the most actionable unanswered question. ## SEO tags. Puma Punku Mystery, H Blocks Bolivia, Ancient Stone Precision, Geopolymer Ancient Stone, Davidovits Geopolymer Theory, Puma Punku Machine Stone, Tiwanaku Bolivia, Andesite Organic Matter, Puma Punku Cast Stone, Ancient Construction Methods, Sub-millimeter Stone Carving, Ancient Bolivia Archaeology, Puma Punku Explained, Stone Precision Ancient, Altiplano Megalith.